So it's really important to understand the relationship between physics and calculus. Right here is the derivative power rule, and notice I have a worked out example here as well. Now these derivatives will also be applicable in physics, where the derivative of your position with respect to time is velocity, and the derivative of velocity with respect to time is acceleration. We can visualize this by looking at three graphs, where the graphs represent position, velocity, and acceleration. Now let's say I have this function, which represents position. So in this case, I can plot this function on this position graph right here. Now what I'm going to do is take the derivative of this function using the power rule. Taking this derivative, I should end up with 2. And this is going to be the velocity function, since the time derivative of position is velocity. Now notice here, if I plot this function on our velocity graph, it's just going to be a constant value. Since we got a constant value of 2 right here, it's going to constantly be 2 on our velocity graph. Now what if I take the derivative of this velocity function, which is also the second derivative of position with respect to time? I'll end up with the derivative of 2. Anytime you take the derivative of a constant, you're going to end up with 0. So our acceleration is going to be 0 meters per second squared, meaning we don't have an acceleration in this system.